Okay, let's define a few terms here. Isosceles triangle we actually saw in some of the proofs that we practiced last time, and that's just a triangle that has at least two congruent sides. So the key word here is at least. So a triangle that has three congruent sides we would also consider isosceles. Equilateral triangle is a little bit more specific. It's a triangle whose sides are all congruent. So specifically, it has to have three congruent sides. There's a few things we want to name in an isosceles triangle. So the congruent sides, we call those the legs. So I'll identify them in the picture here. So this is the leg, and this is a leg. Those are the congruent sides of an isosceles triangle. The third side we call the base. So this is the base. It's the third side. The intersection of the two congruent sides forms this angle. That's what we call the vertex angle. Okay, so the two congruent sides form the vertex angle. And the two other angles here, these are what's called the base angles. Base angles. Okay, so that's a base angle and that's a base angle. So there's one theorem here. We'll state the regular theorem and then the converse. The theorem goes this way. If you have an isosceles triangle, so meaning you have those two sides congruent, then what we can say is those two angles are congruent. The base angles are congruent. Or the converse of that, if you have a triangle and the base angles are congruent, then the two opposite sides or the legs are also congruent. So that's pretty easy, I think, to understand. Okay, let's take a look at a proof here and let's mark up what we have. So this is already marked up. This is not quite marked up, but we can say later on that angle 1 is congruent to angle 2. And we will also know later on that XB is congruent to itself. And we'll end up using CPC-TC. So take a moment and think about what you would do. Maybe pause the video if you want and do your own proof, and then unpause and check if you got the same thing. Okay, first step I would say after the given is just state angle 1 is congruent to angle 2. That's the definition of angle bisector. Then I would say segment XB is congruent to segment XB. Make sure you have the segment symbols there. I'm still seeing students without that sometimes. What I'm going to do next is state that the two triangles are congruent, and looking at what I have here, I have a side, an angle, and then a side. So I know it's going to be SAS. The important thing to note is that the order has to be correct. So if I choose in this order YXB, that has to be congruent to triangle. Well, angle Y is corresponding to angle Z. So I would have to start with Z if I was to do this correctly. So ZXB. And then lastly, we can say what we wanted to prove. Angle Y is congruent to angle Z, and that is by corresponding parts, or congruent parts of corresponding parts of congruent triangles are congruent. CPC, TC. Okay, go ahead and try these problems on your own. Maybe pause the video first. AB congruent to CB, yes, because angle A is congruent to angle C. So then you can say AB is congruent to CB using the converse of the isosceles triangle theorem. Okay, for this next question, let's answer the first part. Is WVS, okay, WVS congruent to angle S, right? So angle S. So again, I would say yes, because what do we know? We know that these sides are congruent, so we can also say the base angles are congruent by the isosceles triangle theorem. The second thing says, is TR congruent to TS? So let's kind of see where that's going on. TR here, TS here. And again, we can say yes, because from here, remember, we showed that these are congruent, and that's also congruent to this. So overall, it's a little bit confusing, but basically this angle is congruent to this angle. And so again, I would say yes by the converse of isosceles triangle. Let's look at the last question. Can you conclude triangle RUV is isosceles? So since we don't have enough information, like I don't know anything about this angle, I don't know if these sides are congruent, we would say no, that there's not enough information. Okay, go ahead and try this next one and pause the video to give yourself some time. Okay, it's really easy to rush this, but let's take our time. So let's see here. John Han, I know this is 54. What is angle C here? That's right, it also has to be 54 because of the isosceles triangle theorem. These two sides are congruent, so those base angles are congruent. So how would I find this whole angle then? Owen? That's right, I would have to do 180 minus 54 minus 54. Very good, Owen. So that would give me 72, but keep in mind that angle x is, or that x is half of that, so it should be 36. Let's take a look at this theorem that many of you have been trying to use actually in some of the proofs yesterday, and it is obvious, but it's something we haven't been proven yet, so either you're going to prove it on your homework, or maybe it would be a really good quiz question. And essentially, here is what it says. If you have an isosceles triangle, so you have an isosceles triangle, and you happen to have a line that bisects these angles, okay, so here ACD, BCD, then what that implies is that that is also on the segment bisector of the base, so these two get bisected. And furthermore, it gets bisected in a perpendicular way, so it's on the perpendicular bisector of the base. Again, really obvious. You can prove that using CP/CTC, but I'll give you some time to think about that. And maybe ask it on a quiz or on the homework. So here we have a new term, this idea corollary. So what is a corollary? A corollary is sort of a result of a theorem. So it's like a little mini theorem that you can deduce from the bigger theorem. So in this one, it's talking not just about isosceles triangles, but it's talking about equilateral triangles. And so what it basically says is if you have an equilateral triangle, so all three sides are equal, then you have what we call equiangular triangle, meaning the angles are all equal. And in fact, we know the angles have to be 60 because there's 180 in a triangle, and you divide that evenly by 3, you'll get 60 degrees per vertex. That's something you've probably seen before. And then the converse of that is just the opposite. If you have an equiangular triangle, meaning the angles are all congruent, then you have equilateral, meaning all the sides are congruent. Go ahead and try problem 3 on your own, and I will either check that on your notes later or we can go over it in class next time.